Hello students, in our today's class I'll explain about the preparation methods of carbonyl compounds. That means we'll discuss both preparation of aldehydes and ketones. Okay, there are many methods in this preparation. We have in first method today, that is nothing but from acid chlorides. From acid chlorides we can prepare the aldehydes. That means we can prepare both aliphatic and aromatic aldehydes. This reaction is also called as the Rosenmund's reaction, as this scientist discovered this reaction particularly. So let us see the reaction and its mechanism. So firstly I am taking the acid chloride. Okay, acid chloride I am adding the hydrogen H2 in the presence of palladium and barium sulfate. This is a catalyst which is helpful for the addition of the hydrogen to the H2 molecules to this particular CO bond. Okay, so acetyl chloride is converting into acetaldehyde because of the addition of hydrogens, and remaining hydrogen and chlorine ions combining together and coming out as a HCl byproduct. Okay, so here I am taking the normal aliphatic acid chloride and to produce the aliphatic aldehydes. So next step I am taking the aromatic acid chlorides to convert that into aromatic aldehydes. So if I take the benzoyl chloride, if I add the hydrogens H2 in the presence of same catalyst, I will get the benzaldehyde and HCl as a byproduct. Okay, so acid chloride is what? Acid chloride means here it is obtained from acid. So if I take the acid functional group, already you know RCOOH. Okay, R can be any aromatic or aliphatic group here. Any alkyl or aryl groups you can take here. So here OH is replaced by Cl. Okay, OH is replaced by Cl and getting the acid chloride. So as it is obtained from acid, we can call it as a derivative of acid. So in second step, I'm taking the acetic acid. In acetic acid, I'm replacing this OH with Cl. Hence, it is called as acetyl chloride. You can clearly see acetyl chloride. Acetyl chloride is converting into acetaldehyde. Same way, benzoic acid I'm taking. I'm replacing that OH with Cl. Okay, here I'm getting the benzaldehyde as a product. Okay, so let us see the mechanism of the reaction. I'm taking the acetyl chloride first. Okay, to this I'm adding the H2 in the presence of palladium and barium sulfate. So this catalyst helps to add the H2 molecule. So when I'm shifting this bond, and I'm shifting this C double bond O towards oxygen. You know, oxygen is a more electronegative atom, so it gets a negative charge. Carbon gets the positive charge. So this hydrogen is getting added on this. So one can get the positive charge, one can get the partial negative charge in these two hydrogens. So the one which is having the negative charge attacks on this particular carbon which is having the positive charge. Okay, the one which is having the partial negative charge attacks on this carbon, and the one which is having partial positive charge attacks on this oxygen to get the C double bond O. No, we will get the OH bond here and we will get the H bond here. Here double bond is getting broken, so double bond breakage is taking place in this step. In next step, what I will do, I'll remove this Cl. Okay, I'll remove this Cl in the form of negative charge. It is being electronegative, it attracts electrons towards itself and getting the negative charge, and this carbon gets the positive charge now. So what will happen, this oxygen is having lone pairs, no, it donates the electrons to this carbon and produces a double bond. We will get the double bond here. Okay, this positive charge and this lone pair of electrons forming a double bond. As oxygen is donating electrons, it gets the positive charge. Okay, in next step what I will do, I need to nullify this positive charge. So I'll remove this H in the form of plus. Okay, this hydrogen donates electrons towards oxygen and coming out as H plus. Then this oxygen's positive charge is nullified. So finally I am getting the product aldehyde, that is acetaldehyde. So same mechanism we can do with the benzoyl chloride, will get the benzaldehyde as a product. So if we observe this entire mechanism, we'll get the two main steps. First step, the addition of H2 is taking place to this carbonyl group. Okay. Second step, there is the elimination of HCl. H plus and Cl minus together coming out as HCl. So these two steps are very important in this mechanism. Okay. So this is about the formation of acetaldehyde from the acetyl chloride. Okay, so thank you so much for watching. So next method of preparation of aldehydes and ketones is from 1,3-dithiene. Here 1,3-dithiene is reacting with N-butyl lithium. Here N-butyl lithium can break into CH2 minus and L plus. So this CH2 minus attracts this H plus and coming out as a C4H10. Here we are getting the carbanion, 1,3-dithiene carbanion is coming out, and this carbanion is protected with Li plus charge, lithium positive ion. And now this 1,3-dithiene carbanion undergoes SN2 mechanism, that is substitution, nucleophilic substitution reaction is taking place. So here chlorine, here nucleophile is removing from outside, here leaving group is moving from outside, and this carbanion is attacking from the back side. You can clearly observe. Okay, so now you can see here there is a formation of C2H5 bond. Okay, with this carbon, this is one carbon, with this carbon there is a formation of C2H5. This is called thioacetal. So now what will happen? It further undergoes hydrolysis. Hydrolysis takes place in the presence of mercurous chloride and methanol. Okay, so now you are getting hydrolysis. No, here protons will be added this side, hydrogens will be added to the sulfur side, and OH will be added to this carbon side. So finally we will get this 1,3-propane thiol, one product, and it is obtained as like this. You can observe. Okay, C2H5H and dialcohol is produced. It further undergoes dehydrolysis. That means water is removed from this structure and you will get the propanol as the product. So finally you are getting the aldehyde as a product in this reaction. Okay, so next let us see for the ketones. How we'll prepare ketones? By using 1,3-dithiene. Same 1,3-dithiene I am taking here. I am adding N-butyl lithium in the presence of tetrahydrofuran. Same N-butyl lithium abstracts this proton and coming out as 1,3-dithiene carbanion. Here carbanion generated. This carbanion is further undergoes reaction with alkyl halide. So alkyl halide, here you can observe I am taking RX. R can be any alkyl group, X can be any halide group. So X will be leaving. This is X is a leaving group. It is leaving from the front side, and this carbanion is attacking from the back side. You can see attacking from the back side, and you are getting this R as a bond. Here this carbon is forming bond with the R. So you are getting thioacetal. Thioacetal is generated now, and this thioacetal is further reacting with N-butyl lithium and tetrahydrofuran. So it is reacting with N-butyl lithium now. So again this hydrogen is replacing with carbanion generation. This hydrogen is attracted by this butyl group and coming out as C4H10. So now you can see here this carbanion is generated. This is called thioacetal carbanion, and it is protected with the lithium group again. So now again one more reaction taking place. One more reaction with alkyl halide. X is acting as a leaving group and it is moving from the front side, and this carbanion is attacking from the back side. So now you are getting this. There is a one more bond with this. This carbon is forming bond with this R. You can see there are two R groups at this carbon. You are getting this as a thioketal. Okay, now this thioketal further undergoes hydrolysis in the presence of mercurous chloride and methanol. You can clearly observe. So now you are getting this 1,3-propane thiol, and along with this you will get ketones. Same product will be obtained like this, two R groups, and there is a dehydrolysis. Then you will get this ketone as a product. So the two same reactions are taking place, but there is a 2 times reaction with N-butyl lithium in this ketone formation. So 1,3-dithiene is useful for the product formation of both aldehydes and ketones.